All right, guys, welcome to a quick little review of my lecture the other day. We started out the lecture with a question. So the question was something like this. Given two numbers, which one is bigger? Okay, and in this case, you can see that it depends on your definition of the word bigger, right? Because I see that 6 written here is clearly bigger than how the 25 is written in terms of its size. But if we think of bigger as which has the greater amount, then we might say, well, $25 is certainly better than $6 because it's bigger, there's more dollars. So you could make an argument that 25 is also bigger. This leads to a problem in communication when you have a word that is not clearly defined. So I gave you a Millerism, and I said that specificity is a necessity. And we talked about specificity comes from the root word specific. Okay, so in mathematics, and particularly in geometry, it's really important that all of our terms are defined specific to what we're trying to do. And so if we wanted, for example, to say that 25 was greater than 6, we could either use the term greater, or we could even use the symbol for greater, which is that right arrow. Okay, and then because this specifically means that 25 is to the right of 6 on the number line, then we would all agree that there is only one correct answer. 25 is greater than 6. Notice that the greater than symbol comes from the right arrow on our number line. Okay, we also may change things up a bit and say 2.5 is not greater than 6, because if 2.5 is here, 6 is somewhere to the right of it. Okay, but we could use the very specific term and the very specific symbol less than. And we could say 2.5 is less than 6. The less than symbol, of course, comes from left of. We can think of this as meaning 2.5 is to the left of 6 on the number line. Now, we don't have to say all of that. We can simply say 2.5 is less than 6, and all of us will agree because those terms have been very specifically defined. Okay, and that's why specificity is a necessity. Okay, and you're going to hear me say that Millerism all year long. Millerisms either teach you something about math, they teach you something about life, or they're just really, really bad puns. That mathematics, we often call it math for short, or the British call it maths for short, actually comes from the word to learn. So the numbers and the symbols that we see are just ways to understand our world and our universe. We talked about the definition of geometry, which has the root word geo, geo meaning earth, this great planet that many of us had visited and that I highly recommend you visit in the springtime. So geometry literally means measuring the earth. In reality, the study of geometry, we study shapes and measurements and all sorts of things about mostly about our three-dimensional universe. You should know that mathematics means to learn. You should know that geometry means to measure, to study the earth. Those are two very important terms. And you should know that math is not the numbers and the symbols. Math is everything that's out there in the universe. It's the language of our universe. And we learn the numbers and the symbols to represent it, just like in music, we use sheet music to represent those beautiful melodies that we hear. All right, so I hope that was helpful. And if you remember nothing else, remember that specificity is a necessity.